Hello everyone, in this lecture we will discuss representation of graphs. Now the first question is why we are studying graph representations. As I told you that a number of real life problems, particularly where we use networks, can be solved using graphs. So for these purposes we need to represent graphs in some mathematical form so that we can perform computations, because it is not easy to perform computations from graphical representation. That's why we represent graphs in some mathematical form, and particularly we use matrices for representing graphs. So here in this lecture we will discuss two such matrices so that you can understand how can we represent a graph in the form of matrices. The first one is incidence matrix. Let G be a graph with n vertices and e edges and no self loops. Particularly here we are discussing simple graphs. The incidence matrix of G is defined as AG. Aij is ijth element and n order is n by the number of rows equal to n, number of columns equal to e, and the Aij, that is ijth element of this matrix, is defined as this equal to 1 if jth edge is incident on ith vertex, 0 otherwise. Now let us have one example. I draw a simple example. Say this is V1, say this is V2, say this is V3, and say this is V4. Now suppose this is as E1 and say this is as E2. Now suppose take only two edges. If I have to write the incidence matrix of this graph, say this graph is G, V, comma I. So for instance matrix, the number of rows equal to number of vertices. 4 vertices are there. So here write these vertices V1, V2, V3 and V4, and here write edges, only 2 edges are there. So that's why the order of this matrix will be 4 by 2. Now to fill these entries, go to the definition of this one. If jth edge is incident on ith vertex, then it is 1, otherwise 0. It means look at this as E1. E1 is incident on V1 and V2. So E1 is incident on V1. It means this entry is 1. E1 is incident on V2. So look at this entry will be 1. Similarly, E2 is incident on V1 and V3. E2 is incident on V1 and V3. So these two entries will be 1. All other entries will be 0. V4, there is no edge which is incident on V4. Therefore, this is 0. So this is the incidence matrix of the graph GVE. Now some of the characteristics of this incidence matrix. If you find the sum of each column, look at this, the sum of these entries of this first column is 2, again the sum of the second column is this is 2. Why it is 2? Because every edge is incident on 2 vertices. That's why the sum of the entries of each column will be 2. So if you write any other entry 1, then immediately you can check whether the matrix is correct or not, because there must be only 2 entries which are 1 in a column. So this is the incidence matrix. One another characteristic. If you find the sum of the rows, look at this. The sum of this first row is 2. This is 1. This is 1. This is 0. So what does this? What is the meaning of this 2? Look at this. The degree of this vertex V1 is 2. So the sum of the entries of a row, this number gives the degree of the corresponding vertex. Similarly, the degree of V2 is 1, the degree of V3 is 1, and the degree of V4 is 0. And you can immediately, if the sum of the entries of any row is 0, then you can immediately say that this is the isolated vertex. So in this way, you can write the incidence matrix of a graph. Now another matrix, adjacency matrix. This is basically alternative to incidence matrix. Let G be a graph with n vertices and e edges. Then the adjacency matrix of G is defined as Xg. Xij is the element. Order is n by n. It means it will be a square matrix. And the ijth element can be calculated as 1 if there is an edge between ith and jth vertices, 0 otherwise. Now look at this. If I draw this graph v1, say v2, and say this is v3. Now v1 v2, say this is e1 and e2. Now the adjacency matrix xg, say this graph is gve. So three vertices are there, that's why the order of this matrix will be 3, and this will be a square matrix. This is v1, v2 and v3, v1, v2 and v3. We have already considered a simple graph. So v1 v1, there is no edge between this v1, no self loop is there, so this is 0. Now v1 v2, v1 v2, there is an edge between v1 and v2, so this is 1. v1 and v3, this is 1. So v2 v1, if there is an edge between v1 v2, then automatically there is an edge between v2 and v1, so this is also 1. This is v2 v2, 0. v2 v3, there is no edge between these two vertices, this is 0. Now v3 v1, there is an edge, this is 1, and v2 v3, no edge, this is 0, this is 0. So this is the adjacency matrix of the graph GB. Now if you look at this, this is a square matrix and this matrix is symmetric. Why symmetric? Because as I already told you, if E1 is the edge between V1 and V2, you can say E1 is the edge between V2 and V1, because here this is undirected graph, no direction is given to the edges. So this matrix is symmetric matrix. Now again the same thing, if you find the sum of any row or column, then this will give you the degree of the corresponding vertex. For example, degree of v1 is 2, degree of v2 is 1, and degree of v3 is 1. So in this way you can write adjacency matrix. So these are the very simple ways to represent a graph in the form of matrices, because from this matrix alone you can again draw the graph, this graph, because from where you know that the three vertices are there and there is an edge between v1 and v2, v1 and v3. So you can draw the graph with the help of this matrix, and you can perform calculations also. So I hope that you got the concept of these two matrices. Two other matrices are there, but for these matrices we need some additional concepts. Only then we can define these matrices. So far we have limited or we have restricted our discussion to these two matrices only, and I hope that you got the concept of these two matrices.